Orthogonal vector. Orthogonal means perpendicular. Let these two vectors A and B. A may be force or velocity, B may be force, velocity, or any other vector. These two vectors are perpendicular. They act at 90 degrees to each other. Then we can call them orthogonal vectors. If the vectors A and B are mutually perpendicular, A and B are orthogonal vectors. Let us take the example of three orthogonal vectors: x-axis, y-axis, and z-axis. This is the xy plane, this is the yz plane, xy plane, this is the yz plane, and this is the xz plane. Let us take a vector here, let it be A. AX along or AX in xy plane, B vector X in yz plane, and C vector X in xz plane. Since these planes are mutually perpendicular, therefore these vectors must be mutually perpendicular. Is it so? This is a quiz question. Can the vectors A, B, and C acting in xy, yz, and xz plane respectively be orthogonal vectors? You can answer this question, but I can give you another example of orthogonal vector. Let me redraw the diagram of this Cartesian coordinate system. X-axis, y-axis, and z-axis. If the vector A, x along x-axis, vector B, x along y-axis, and vector C, x along z-axis. The angle between A and B is 90 degrees. The angle between B and C is 90 degrees. The angle between A and C is 90 degrees because x, y, and z axis are mutually perpendicular. In this case, we can say that A, B, and C are mutually perpendicular vectors or orthogonal vectors or orthogonal vectors. But in this case, when the vectors are acting in three mutually perpendicular planes, can these vectors be orthogonal? When the vectors act along mutually perpendicular lines, they can be orthogonal. But if they are acting in three mutually perpendicular planes, can they be orthogonal? This is the quiz I have given to you. Dear students, this quiz it's not so difficult quiz. If you can answer this quiz question, definitely I will give you more and more interesting quiz for the students, those who are very much interested in answering this type of very interesting and very fascinating quizzes. Through the quizzes you can clear so many interesting doubts. You should not say it's quite difficult. Difficult, the word should not be used in physics. When you understand the concepts, when you understand the theoretical portion of physics very effectively, very neat and clearly, the word difficult will be more interesting. So please don't use the word difficult for understanding physics. The physics is interesting. It's quite a simple quiz. And please drop the answer in the answer box in my YouTube channel. In this foregoing discussion of types of vectors, we have categorized the entire vector into several types like parallel, antiparallel, equal, negative, orthogonal, and so on. All these vectors now can be divided into two different types of vectors like polar vector and axial vectors. Any vector you take. It can be either polar vector or it can be axial vector. General students face difficulty in understanding the basic difference between the polar and axial vector. Let me discuss one by one. First of all, we need to understand what exactly the polar vector is. Polar vector. Any vector like position, velocity, displacement, acceleration, force, etc. endowed with a translational motion we'll talk about translational motion in kinematics. This type of vectors have a definite point of action. Where these vectors act, we can easily notice. Suppose mango is hanging at this point. The string is connected here, and the mango is pulling this point P downward. Mango is applying a force in this way. So this is the force that mango is applying. Gravity is applying a force in this way on the mango. So this force is having a definite point of action. This force F1 is acting at this point P. This force F2 is acting at this point Q. So this is the point of application of force F2. This is the point of application of this force F1. So force is a polar vector. Similarly, with respect to this origin, this mango has this position given by a position vector. The position vector is acting at this point. This is the beginning, this is the end of the position vector. So this is the point of action, definite point of action. Therefore, position vector is a polar vector. So polar vectors are the vectors having a definite point of application. The vectors having a definite point of application are known as polar vector. Generally, the polar vectors are associated with the translational motion, not rotational motion. And you can clear this translational motion in kinematics of a particle and dynamics of a particle. Now, axial vector. The axial vectors are pointed towards a particular direction at a particular instant. The direction of any vector may change from time to time. But the direction of the axial vectors must point along a particular axis. This is in rough sense. To understand it, let us take an example of an object, say a rotating top. The top rotates, it spins in this way. When it spins in this way, we have the right hand thumb rule. When it's spinning in this way, the spinning direction is given by the curling of your finger. The finger curls in this direction of the spin, and the extended thumb will give you the direction of spin. About this axis, the top is spinning. This is a sense of spinning. And this is the direction of spin is given by a right hand thumb rule. We will discuss the right hand thumb rule in separate section. This is the angular velocity. Of the spinning top. This is the spinning top. Angular velocity is pointing along this axis of rotation. This is the rotational axis. axis of rotation. Angular velocity points along the axis of rotation, but it is very difficult to say at exactly which point the angular velocity vector is acting. There is no definite point at which angular velocity acts. No definite point of action. We cannot say exactly at which point angular velocity vector is acting on the top, but definitely it is acting along the axis of rotation. Maybe if you draw the vector in this way, you draw the vector in this way, you draw the vector in this way, if you draw the vector parallel to the axis of rotation also, it is correct. So in this way, the exact point of location, the exact point of application of this vector is unknown. We cannot define the exact point of application of the angular velocity vector. So this is called the action vector. The vectors having no definite point of application are called action vectors. These vectors are generally endowed with rotation. These vectors are endowed with or related to rotation.